Now that we've introduced polygons and the rotation reflection translation, we're going to go a little bit more deeper into this. And this is actually chapter 3, section 1. So we were in chapter 1, section 6 and 7. So just note that. Also, as a reminder, you watch this video and you take notes on the guided notes that I left for you in your OneNote notebook. It does not match the PowerPoint, so you're going to have to think about it and pay a little bit of attention to what's going on here. Okay, so we're going to talk about reflections in a line. A reflection in a line is just, it says it maps a point to its image, such that if the point is on the line, so in other words, if this is our reflection line, I'm going to call that line of reflection right there. If there's a point A and it's on the line, the reflection is exactly identical to itself. If A is not on the line, this is the pre-image. Pre-image in our book, they're always blue. Pre-image you also know because there's not a tick mark on them. So see how this is A prime? This is the image. So A has transformed to A prime. So A is the original, A prime is the new thing that happened. Notice that the distance from A to the reflection point, the reflection line, is identical, and that distance is always measured perpendicular. So it says if the point is not on the line is the perpendicular bisector of the segment that joins the 2 points. So the reflection line, the distance from the reflection line to any point on a figure is perpendicular to that line. And you can see these in the pictures as well. You've got a line of reflection. Horizontal reflection means that it flips across. Vertical reflection means that it flips up and down. So this would be the y-axis. This would be the x-axis. There's some notation you need to know. This is how we go and define transformations with coordinate points, and it makes it actually very simple. Looks complex, but it's not so much. To reflect a point in the x-axis, multiply its y-coordinate by -1. So for example, the blue line AB has a coordinate point at 4, 1, and it's reflecting over the x-axis. There's our reflection line. So if I reflect that over the x-axis, this 4, 1 point now becomes 4, -1. And what's different between these 2 points? It's the -1. It started out as a 1 and now it's a -1. So our 4, 1 changed to 4, -1. Notice the only thing that's different is that the y value, the original y value, is now negative. The reflection in the y-axis, notice the image, the pre-image has 2, 3, and then it switches to -2, 3. So what changed from the original? The 2 is now a -2. So anything that is reflected over the y-axis, if you know the coordinate points, you can just change the sign of the x value to get the new one. So for example, look at, well, B is at 6, -4. That's point B. So the new value of it is at -6, -4. Everything stays the same except that. Then we have one called a reflection over the line y equals x. The line y equals x is a line where every single x value is identical to every y value. So if this were 1, 1, that's what the coordinate point would look like on that if that was 1 and 1 at those locations. So to reflect a point in the line y equals x, all you're going to do is you're going to change the x and y value. Look at the original here. It was at 2, -5. Reflected over that line y equals x, it's now exactly the same signs and everything. We've just switched. So you need to memorize these and get these figured out so that you can tell us how things are reflected. Who would use these? Programmers, video game people, that's the big one. If you have a reflection like the sun in a video game reflected, or an anime reflected on a lake, probably there's a reflection algorithm somewhere in there. Algorithm is just another name for an equation. All right, so which is reflected image of quadrilateral ABC in the line N? You figure that out. pause the video, and then come back. So when we're looking for reflecting over a line, we're looking that the distance from B perpendicular to the reflected line is exactly identical to the other side. If you look at B, that's not happening here. Point B is way over here. It shouldn't be. So that one's not the answer. If you look at the B on this one, it kind of looks like it might be, but then you check out the C. Look at the C's right there. That's the distance to the line of reflection. Here's the distance to this line of reflection, and they're not on the same perpendicular line. That the line of reflection has not made a perpendicular bisector between the image and the pre-image. But if you come down to C, to go from D to D prime, we draw this line perpendicular, and look at that. That looks like that the line from D to D prime is perpendicular to the line of reflection, and it's split in half. So C would be our 1, because if we check that out with all of the other points, then it works the same. I'm going to start this one for you, and then I want you to finish it. So in just a second, pause the video. We're looking at a reflection of this quadrilateral over the x-axis. So here's the x-axis. So if we think about our reflections, if I'm reflecting over the x-axis, that means our new C value is going to be opposite across that reflection line, and it's going to be the same distance. Our C prime will be right there. So what's happening here? Well, x is at 1, 2, 3, 4, and y is at -1. But if I reflect that point over the x-axis, it's going to be at 4, 1. So what's happened? Well, the x value stayed the same. The y value is opposite. So for the first point, A, 1, 1, the x value will be the same. That y value will be opposite. You try the rest, pause the video, and then come back. Okay, let's check how you did on the other ones. So B is at 3, 2. So the pre-image is at 3, 2. So the image has to be at 3, -2. C is at 4. Now this one already is negative, so it's going to be at 4, 1. D is going to be at 2. The sign is opposite. So you could think of this negative as opposite sign. So this is at 2, 3. So then we'll draw the picture. A prime is at 1, -1. So that would be right here. I'm going to label this as A prime. I've already got C prime labeled over here. I'm going to turn it orange. Okay, B is at 3, -2. So I go over to 3, but -2 down. So this is really helpful when we have these overlapping ones like this. Sometimes things don't look like these where you've got one thing on one side and the other thing on the other side. Sometimes they reflect in the middle of an object, and this helps with that. D is at 2, -3 for the original, so the image is going to be right there. That's going to be our D prime. Again, prime is the image. The ones without the prime are the pre-image. So now if we draw that, do you see the reflection going on there? So for this one, I'm going to have you develop this one and you figure it out. The rule again on this one is XY goes to, we switch the Y, we switch the X, don't change any signs. How'd you do? Okay, check your numbers, make sure you got it. Make sure if there's anything you need some help with, you make a note of it to ask me. And the last check is it should look like it when you graph that it is a mirror image over that line. A translation is just a slide, but it's a slide in a direction we call the translation vector. So every point on these shapes go the same distance over, same distance up, every single one of them. If I call the distance over an addition of A and the distance up an addition of B, then we can develop a rule for this, but we're going to call this a translation vector, and the vector looks like this. So it's going to be however far over A, however far up or down B. So the vector form of a translation just takes how far we move over left and right, how far up and down. So we're going to talk about the vector form of this a little bit more detail, but we want to see which of these shows a translation along the translation vector. In other words, it goes the same direction. So you pick the one that you think belongs and then start the video again. One way to do this is just to draw a line from the initial point to the new point and see if it's the correct one, then the line should pretty much follow what we've got going on with the vector for every single one of these. So I would say A is the correct one because C is a little backwards, B is side by side, and D is way too steep. So in the symbols, the rule for transformation that we were talking about with reflection, we had one rule. For transformations, it looks like this. So in other words, we're taking whatever the x value is, and then to get from this point over to the next one in the x direction would be our a. So in this case, a equals 7. Then we went up 4, so that's our b value. So this is x plus a, y plus b. The original plus the move is what you're doing. And you can get that vector. The vector has the a and b there, so you should be able to write it both ways. You either write it like -2, 3 goes to p prime of -2 plus 7, 3 plus 4. Or you write it as a vector form depending on what's being asked for. For example 4, we're asked to graph TV the new triangle along its transformation. So it gives us a vector. We should know from that a is -3 and b is 2. So you see what I did? I took this the rule and I turned it into x, y as the original as the pre-image. And then in the image, I'm going to take whatever the x value was, and I'm going to take away 3 this time, and then I'm going to add 2 to all of the y values. So you try this and then graph your triangle, see if it makes sense. All right, how'd you do? So you should be at 3, 4, and you can also do this on a graph. It's real easy. 1, 2, 3 in the negative x direction, and then 2 up. So you should be able to see that same pattern every single point on here. Now you're going to find the translation rule. In other words, what is the rule for this? I have x, y, the original point, will become x plus a, y plus b. We need to see what the rule is for this. So start with a, and it looks like the pre-image is a, so you have to be able to identify the pre-image and the image. So I'm starting at a, and it looks like I'm going to go over 1 space, 2, 3, 4, 5, but it's going to be in the negative x direction. So this is x minus 5, and then the y value goes down 1. So that would be the rule for this translation. And so as a vector, it would be -5, -1. Rotations are a little different. There's a center of rotation, and clockwise and counterclockwise, you've got to make sure you know that. This is counterclockwise. I abbreviate it like this. This right here would be clockwise. There's some real nice rules that set this up. We talked about how the center of rotation, you always keep the distance from the point to the center of rotation the same when you rotate. But the rules that go with this are these. If you have a 90-degree rotation, turns out that the rotation is just simply switching the letters. So you're going to negate the y, and then you're going to switch it over to here. 180 degrees, and these are clockwise rotations, so counterclockwise rotations. 90 degrees rotation is the same thing as counterclockwise is the same thing as 270 degrees clockwise, just so we got that out of the way. 180 degrees rotations are clockwise or counterclockwise, and then 270 rotation is counterclockwise. You're going to switch the letters and you're going to negate the x. You negate the x and the y on the 180-degree rotation, but you don't switch it. The last example on here, the rule is 90 degrees counterclockwise, so you're going to switch the x and the y and